The problem on the board is also a composition of a trig and an inverse trig function, but there's no way that this function is going to undo what that function does, because they can't possibly be inverses. This is arc cosine, and that's sine. However, when I have a composition of trig and inverse trig, I usually can figure it out. And what's interesting is I can, without a calculator, evaluate sine of arc cosine of negative 0.2. I can't, without a calculator, simply evaluate arc cosine of negative 0.2. I know this is going to be an angle, but I'm not going to be able to find its radian measure. But I am going to be able to find its sine. Okay. So here's what I'm going to do. I know that arc cosine spits out an angle. So I am going to give that a name. I'm going to call that theta, and I'm going to record the information that I know about theta. I know that cosine of theta is negative 0.2, and I know that theta is in the interval from 0 to pi, because that's the range of arc cosine. Okay. Now, when I have a decimal like this, I'm almost always going to convert that to a fraction, because all of the outputs of my trig functions I like to think of as ratios. So if I rewrite this as negative 2/10, because that's the name of that decimal, I can then reduce and say it's negative 1/5. I think it's going to be easier to work with in that form. So that's going to be my strategy anytime I encounter a decimal. Okay. So what I'm going to do is, without figuring out the exact radian measure of theta, I'm going to record the information that I know about it. So I know these things. Well, if it's between 0 and pi, it's either in quadrant 1 or in quadrant 2. That's negative. Of these two quadrants, the one where cosine is negative is quadrant 2. Now, that's going to help me in evaluating sine. Because in evaluating sine of an angle, I like to do it as this two-step process. I'm going to figure out whether it's positive or negative, and then calculate the absolute value. Well, we're in quadrant 2. Sine is positive in quadrant 2. So notice this plus or minus sign told me the quadrant, which told me this plus or minus sign. Kind of cool. Okay, now if we're in quadrant 2, I know that that's what my theta looks like, and then my reference angle alpha would be an acute angle in here. Okay. Well, what I know about alpha is that cosine of alpha would be the absolute value of negative 1/5, which would be a positive 1/5. Okay. And I know that the absolute value that I want to attach here is going to be sine of that same reference angle alpha. It's going to be sine of alpha. Sorry, lost my train of thought there. Well, what I'm going to do is just use some right triangle trigonometry here, and that's why I found it helpful to have a fraction rather than a decimal. Here's alpha drawn as an acute angle in this right triangle. I'm just going to label the sides. Now, I'm not going to label sine sides because I've already done everything I need to do with sines. I'm labeling things for alpha, not for theta. Okay? So, if cosine of alpha is 1/5, the adjacent side would be 1, and the hypotenuse would be 5. Now, sine of alpha, which is what I'm going to put right here, that's going to give me the correct absolute value for sine of theta, which has alpha as its reference angle. That's just going to be opposite over hypotenuse. So I need to figure out what that opposite side is. Well, I know how to do that. That's Pythagoras. So I can say 1 squared plus p squared equals 5 squared. 1 plus p squared equals 25. P squared equals 24. P, algebraically, there would be two answers, but because I'm looking for a side length, it's positive the square root of 24. That's the square root of 4 times the square root of 6, and of course I can simplify the root 4. So that's 2 root 6. Excellent. So now I just apply SOHCAHTOA to get sine of alpha, 2 root 6 over 5. So that's my answer. Notice I did not figure out what the radian measure of theta was, but I was able to figure out the triangle that I could associate with it and what quadrant it was in, so I was able to evaluate sine. And in a similar way, I'd be able to evaluate any trig function at this particular angle.